And this is also I need to put?
No, this is for here.
Okay.
This is forward, this is backward, this is laser pointer long this.
Okay, thank you. Okay, good afternoon and welcome to this session. I am Sayan Gupta. I am the head of the Department of Applied Mechanics and Biomedical Engineering. And this session is about this computational engineering and mechanics. So just before we talk about this, I'll give a brief background of our department. This is one of the founding departments of IIT, so Madras. So it's as old as the institute. We started off as applied mechanics and aerospace engineering. Then 10 years later, aerospace engineering became a separate department. So we were applied mechanics for a very long time. Till 2024, we changed our name from applied mechanics to applied mechanics and biomedical engineering. One of the reasons is that we had three primary groups in the department: solid mechanics, fluid mechanics, and biomedical engineering. And we changed the name because we felt that our colleagues in biomedical engineering and our students who were doing biomedical engineering program, they were not getting the sufficient visibility that because in the absence of the name in the department's name. So till last year, we were a purely postgraduate department, and we were the only postgraduate department in the institute. We did not have a BTech program, though we were teaching a lot of BTech courses. And last year, we again became the unique department because from having no BTech programs, we started two BTech programs. One is this computational engineering and mechanics, and the other is instrumentation and biomedical engineering. So I think the session for IBME has already happened around 1 o'clock. So this session is about computational engineering and mechanics. Now, why we started this program? One of the reasons was that, as I already mentioned, that our department had solid mechanics, fluid mechanics. These two were mechanics-heavy department, mechanics-heavy groups. And we had a biomedical engineering group, which was basically electrical engineering heavy group. And by nature of our department, we were very interdisciplinary in nature, in the sense that we have a faculty strength of about right now 36. And of this 36 faculty, we have their undergrad training is from around 12 different disciplines. So from aerospace engineering, civil engineering, mechanical engineering, electrical engineering, instrumentation engineering, biomedical engineering, physics, you name it, we have faculty from these departments. So the way we conducted we had a for a very long time, we have been running MTech programs, and we have our MS and PhD programs are also very strong. We have more than 200 PhD students on rolls. So we were doing very cutting-edge research in areas that required interacting with very different disciplines or different expertise. And that's when we realized that probably this is the right time to start programs which break through the traditional siloed departments that we have been usually having and start new programs that addresses the needs of today's industry as well as research. So this computational engineering and mechanics is, I'll just go to the next slide. So I will first play this video. I'll just use this, I think it's simpler. No.
Somebody who is a relevant engineer trying to build a 30-40 year career cannot do that without a deep expertise in computational engineering and artificial intelligence and data science. This program is a result of a sufficiently long and deliberative process where we studied the evolving landscape of engineering globally and in India particularly. We have these traditional silos of engineering, but we also saw a common thread that runs across multiple, which is the idea of computational engineering. Today, every discipline of engineering has a computational engineering layer.
Data science, artificial intelligence, these are all essentially tools. And these tools can be used in conjunction with mechanics to solve real world technological challenges that are available today. We didn't have an undergrad program for the last 65 years. We had a blank canvas, and using that canvas, it gave us a lot of freedom to devise a program that is very relevant for today's technological world.
So we said, let's take mechanics, blend it in equal measure with electrical engineering and AI and computational engineering, and create a program that would position this graduate for the 21st century careers in a broad range. While there are other programs in other IITs that are called computational engineering or variants of computational engineering, I think the key distinguishing part is where we want to see computational tools applied to real world problems. Every aircraft engine that is on a flying aircraft has a digital twin sitting on their engine manufacturer's computers. The computational model is more or less a replica of the real engine. So I can monitor, for example, the health of the engine. I can monitor efficiency. You first need to know how an aircraft engine works. You need to know the computational tools that you can use to bring that world into the computational world and then operate here. So this idea of a digital twin developer that deeply understands digital twins is one of the stated objectives of this program. The curriculum entails roughly in one-third measure mechanics, electrical engineering, and computational engineering and data science.
Core courses that students will have to go through are basics of electrical engineering, digital signal processing, signals and systems. In mechanics, they will be doing strength of materials, engineering mechanics, thermodynamics, and then they will have to pick up solid mechanics, fluid mechanics. They will be doing Python programming, data structures. Then they will be doing computational. Once you are done with the core courses, they can opt to specialize in 6 particular directions. One of them is energetics and materials, dynamics and controls. Then we'll have the computational aspects of mechanics, digital twins, which is a very important thing in today's world, and mechanics aspects in biological systems, and finally, development of computational methods per se. I don't think there exists any curriculum in the country right now which enables the students to go into this direction.
Then on top of these foundational layers, we build the application layer. The application layer has some core components like the digital twin part that we described and elective components. For example, you could choose to apply this to the world of biomedical engineering and healthcare technologies. You could choose to apply this to gas turbine or aircraft engineering. You could choose to go in the direction of modeling complex networks and complex systems. So we have allowed the student all of the flexibility required to benefit from this foundational layer, go into any sub-discipline and become an expert in that sub-discipline.
First of all, our students we expect them to have a systems level of thinking. So basically, it's not that I'm going to look only in mechanical aspect or the electrical aspect, but it's an overall aspect. So they will be uniquely positioned to take up leadership roles in projects, in very important projects that encompass multiple disciplines, talking with different domain experts.
Somebody who is a relevant engineer trying to build a 30-40 year career cannot do that without a deep expertise in computational engineering and artificial intelligence and data science.
Right. So we'll move on to the next slide. Yeah, so this is actually not a correct schematic, because it's not that CEM 1 is only focused on basic programming skill or CEM 2 is only basic electrical skills. It's actually a mixture of different, CEM 1 you'll be doing basic courses, CEM 2, it's a continuation till CEM 5, by which time you would have finished, students would have finished all the core courses that are required for the curriculum. CEM 6 is only electives, and we have only 4 electives in that semester, because we want to give that freedom to the students if they want to go for an internship in a different institute or anywhere else, because CEM 6 will start from January, so CEM 5 will end around November, and CEM 7 will start around August. So the student essentially, if they want to go for an internship in some other place, you have essentially 8 months time, December to July. So that's why CEM 6, we have only electives and only 4 electives, which if you are planning to go for a internship, you can distribute it, those 4 courses to some other semesters. CEM 7 and CEM 8 are just electives. So basically by semester 5, you are done with all the core courses that are required. Now, as I mentioned, as was mentioned in the video, this program is, focuses on 6 very important pillars: mechanics, electrical sciences, materials, and of course the tools, that is mathematics, computational science, and data science. So the last 3 are, we view them as tools to study science, and the first 3 are domain expert-wise knowledge. And we expect our students, after going through this, to become experts in having the broad foundation in these broad areas, and subsequently they can define their electives in such a way that they can tailor themselves to become specialists in these 6 of these specialization areas: computational mechanics, mechanics of biological systems. I will explain what we mean by this: energetics and mechanics, dynamics, control and robotics, computational methods, and of course digital twins. What do we mean by energetics and mechanics? So for example, nowadays we know that we are talking about electric vehicles. In electric vehicles, battery is a very important thing. So the mechanics associated with these type of materials we have to also understand. So this energetics and mechanics, we are now also looking into various other sources of energy. For example, our department is now involved in a project with nuclear sector, where the objective is now trying to develop what are called micro-modular reactors. Okay, which are modular reactors which need not exist in as large plants, but which you can bring and install it, say, in IIT. So this type of line of research is what we mean by energetics and mechanics, and there is a lot of mechanics knowledge is required, and an agglomeration of mechanics with other issues. Dynamics, control, and robotics, of course, this is quite clear. For example, especially after the recent wars, we have realized that swarms of drones plays a very, very important role. Now, when you are designing these drones, this can't be done only by computer scientists or electrical scientists. It requires integration of large teams involving knowledge of all the disciplines: mechanics, fluid mechanics, solid mechanics, material behavior. These are all battery operated. So again, energy comes into the picture. Control has to be there. And when you are looking into their control of the entire swarm, it's not that each swarm is controlled by a single operator. There is a algorithm for controlling them, is that they are autonomous. So they themselves, each swarm, each participant in that swarm distributes the task, and in the event of a failure, one of them fails, that task gets redistributed. So that's how these things work. So you have to this involves communication. So it's a very, very interdisciplinary type of work. So if someone wants to be working in this type of applications, then this dynamics and control is what they would need to be strong at. Mechanics of biological systems. We have colleagues who are working on, for example, design of how, if you take a medication using sprays, inhale it, how it gets distributed into your lungs. So the mechanics of drug delivery, for example, that is also integration of fluid mechanics, and biology. We have colleagues who are working on development of stents or other devices for for cardiologics, cardiothoracic systems, for nervous systems, etc. Okay, so that's where we say that. Oops, I'm sorry. So so that's what I mean by mechanics of biological systems. We are also looking into development of biomimetic devices. For example, robotic fishes, robotic birds. So the mechanics of, say, the flight of an insect is very different from the mechanics of flight of an aircraft or a helicopter, for example. There has been a saying which is very interesting, that bumblebee cannot fly. This was slightly dated. It was around 2005. There was a paper which came out that bumblebee cannot fly, because at that point of time, according to the knowledge of aerodynamics, a bumblebee should not be flying, but we know it flies. Okay, so there are the physics of flying for this type of insects is very different. And why do we need to study? Because if we want to develop surveillance, robotic surveillance robots, for MAVs and etc., which are flying at very high altitude, they can observe whatever is happening, which are exposed to the ground. But if something goes into the inside a building, they cannot observe anymore. So you need to design this type of robotic insects for this type of surveillance. Not only for surveillance in case there is a fire or if there is a building collapse, you want to rescue people. So this is where this type of things happen, are necessary. We have been also working, for example, robotic fishes. Now, again, one of the issues is that we have been looking into is that how we have seen fishes have, when they swim, they continuously change their shape. So this brings in issues what are called morphological systems, where the systems change their shape as and when required. Number one, the question is, why do they change the shape? There's a physics associated with it. That also needs to be understood. Okay, and we have actually done studies where we have shown that why it is beneficial for the fish to actually take that type of shapes, so that it becomes more energy efficient for this type of systems. So that's what I mean by when I say mechanics of biological systems. I'm just giving some examples in which I am familiar with. I have 38 colleagues. I don't know exactly the ins and out of all the work of my colleagues. Okay. So digital twins of physical systems, that's quite a buzzword these days. For example, in the video, Mahesh already mentioned about the engine, aircraft engine. You can't be doing physical experiments for everything. You need to make digital twins out of it and then do those analysis. And digital twins just does not mean development of numerical methods. It also means integrating your mathematical models with sensors, measurements, and you have to complete the control feedback. So that's why we felt that it is important to have this grounding, this foundational grounding in, for example, in electrical engineering, which I did my BTech in civil engineering, which I never had this opportunity. And so everything I now have to study from first principles. I don't want our students to have that, especially in today's world, to be handicapped like this. So when we talk about digital twins of physical systems, it's basically a integration of mechanics, electrical sciences, data sciences, because you are taking a lot of measurements from sensors, and of course computational methods. Okay. Yeah, so then of course we are talking about computational mechanics. This is a well-known area of which has been in existence for quite some time, but there are many issues. I mean, cutting edge area works is being carried out here, new which are relevant with today's high computing power and so on. And of course computational methods, where if your focus is on development of computational tools, new computational tools per se. Okay, that's where we talk about computational methods. Apart from these are just indicative, electives, specializations. In our curriculum, you have the freedom to take at least 40% of your courses as electives. So our curriculum is of 400 credits. This basically means that you can take 160 credits. You have the choice to take whatever, design the electives, which basically means that you can tailor your specialization according to your need. Okay, so these are only indicative, and in our website we have listed the courses, probable courses, which if you do, you can consider yourself to be an expert in one of these areas. But it need not be. You can tailor it accordingly, according to your interest, according to your choice, according to what you think is interesting. Okay, so we are going back. So this is basically a comparative chart between what is CEM and what is math and computing. So of course, the first philosophy is that, core philosophy is that it's an engineering first approach, where we are applying this to physical systems. So we are always in touch with the problem that we are trying to solve. The primary applications, of course, are digital twins, fluid solid mechanics, engineering simulation, learning systems. By what I mean by learning systems is computational learning, which is again an evolving area of field. By computational learning we are not necessarily always talking about neural networks or we are talking about more advanced machine learning algorithms, which operate on a completely different paradigm than the traditional neural networks. Then physical systems integration, as I mentioned, that it's deeply integrated with mechanics, thermodynamics, material science, and electrical engineering. And of course, in math and computing, let me not talk about that course. This was prepared last year when we didn't have a BTech in math and computing. This year we have a new program on math and computing. We have lab experiments. So we have our program is, we design it in such a way we feel that you should be doing a lot of hands-on activities parallelly to all the coursework that you will be doing. And there will be term projects, there will be experimental or hands-on components to that. We are building, we have in our department, we have around 40 labs, and we are trying to also build two labs directly for UG students, in which they can just play around. That will be ready by this July. And of course, the output focus is on engineered systems, design optimization, and physical products. Again, here I would like to emphasize that the way our generation worked was our objective was, after graduation, we should get a good job. I think in today's world, that has completely changed. Especially with AI coming up, I think the job part might be a bit, it's not the best way to go forward. Given that our students here are the best students in the country, and the ecosystem of IIT Madras, we are said to be the Stanford of India, right? We have a very strong entrepreneurship ecosystem, startup ecosystem. It is our expectation that our students will be the next generation builders of the new Googles, the new whatever Elon Musk things. It should be emerge from here, not from anywhere else. So that's what I think we should keep in mind and not worry about jobs, about what salary we will get. The starting salary is immaterial. You are going to have a career of 30 to 40 years in this field. So you cannot be thinking of only your starting salary. Okay, that's immaterial. So yes. Okay, this is one more video. Let's just go. Oops.
We believe this will change the landscape of research questions that will be asked.
Just if you look at land engineering challenges, they all cut across disciplines. And sustainability is going to be one of the major aspects that have to be taken care of. With all these, there is a lot of scope for somebody who has been trained in CEM to take up positions even of leadership in multidisciplinary domains.
A graduate of this program will have two sets of opportunities. One is, of course, the traditional job. You can look at somebody being called a digital twin developer or digital twin engineer. And there's a whole range of engineering opportunities in the industry there. A second set of opportunities are in research. Because you have two dissimilar bodies of knowledge resident in one person, that person would be able to ask questions that are far richer than somebody who does not have those two bodies of knowledge in one person, and they have to rely on collaborations.
We will offer the courses like sensor materials in a very different way, which will be hands-on. And they will love doing what they are learning. And this is an experience that they will take along with them when they graduate. They will also have exposure to various fundamentals, from electrical networks to sensors and actuators to signals. We are planning to also take them to industrial tours, right, to get them to go outside. Thankfully, we have now research park and all those. Today, infrastructure is such that it is possible for us to get them to explore more.
We believe this will change the landscape of research questions that will be asked as well. And most research problems these days, as we know, require an interdisciplinary approach and an interdisciplinary solution development process.
By 2030, we see AI taking over certain aspects of whatever is happening, whether it is coding, whether it is designing. Looking at this, we started to recruit faculty members in the multidisciplinary areas. Cutting across even within our own groups that we had, fluid mechanics, to solid mechanics, to biomedical engineering.
There's a very active area of research now called complex networks, which is a field that has come up thanks to the vast, expansive networks that we have built for ourselves. Understanding the dynamics of these networks is crucial to how information flows, right? So those are all opportunities apart from digital twins, healthcare, understanding mechanical systems, electrical systems, and designing in silico designs, developing in silico designs of real-world engineered products. And to understanding complex networks, I think the canvas is wide and vast for somebody that wants to paint a career for themselves in the research space. The Department of Applied Mechanics and Biomedical Engineering at IIT Madras has 38 faculty members. We all have our own research lab. It is the most interdisciplinary department in the whole country.
We have 40 plus labs associated with different research topics that faculty are conducting. One last thing is we are also going to introduce mindsets. For example, we will just ask them to explore asking this question: what is mechanics in it? right? What is mechanics in the camera?
So that's who these graduates should aspire to become and be.
Okay, we have one more video next. Okay, this. Okay, the requested file does not exist. So there was one video also here. So what we had done was last year, before we floated this program, we reached out to our alumni, both recent alumni and our former, who are not so recent alumni. We reached out to industry, asking them whether they feel there is a need for this particular program. And we got a very good response. Many of our industry leaders said that if we had our opportunity to study once again, become a student, I would have joined this course. GE, for example, gave a very nice feedback. They have what is called the 2-month Edison program, which is basically a compressed version of whatever they said that it's a compressed version of whatever we are floating as a 4-year program. Because again, it promotes a system level approach to problem solving, to analysis, and so on. And we asked our graduates also, and we got a very good feedback from our recent alumni. We again asked the question, if you were written JE today, what would your rank, assuming that whatever your rank was last when you appeared, what would be your choice, preference of choice? Of course, computer science, data science, they were in number 1 and 2. Electrical and CEM were in the next 2 choices. So that gave us a lot of confidence that yes, it resonates with the students who had gone through the IIT system, and they probably have a better understanding of what all these programs are. For the incoming students, I don't know how, at least if you guys are, of course, are much better informed than what I was at your age. But this is a question that I keep on getting, that my interest is in computer science, or my interest in this or that. I'm not interested in this area. It's primarily my understanding is, even after talking to these kids, is that you guys actually are parroting based on the choices that have been told to you by your neighbor, uncle in the neighborhood, and some relative, and no, do this, this is good. Don't do that, that is bad. It's probably not the correct way to go about the things. So that's why we have this AskIITM team doing all these things. So yeah, so maybe we can ask questions. We have 3 of our students here, our current students, who probably also don't know much about the CEM program yet. Because they just completed their first year. Most of the courses are all basic courses, which are common to most departments. But they are there to tell, if you have any questions, you can also ask me. They are here. Yes, I am available for questions now. So no questions.
Sorry for the background. Do you feel safe enough with respect to placement and future perspectives when you're doing CEM?
Yes, ma'am, because like sir said, starting salary is the material, right? Wherever you start, you're still going to grow. Being a new course, that's what we're learning. We're learning to explore ourselves. There's no senior guiding us here. So with that knowledge in 4 years, we should also learn how to grow and be best.
Makes sense.
So when was this curriculum designed, sir?
Last year. They are the first batch.
And IIC is also starting
From this year.
this year.
Yeah.
So how different is this versus?
So actually, I think they got inspired by us.
Even IIT Kanpur is starting intelligent systems.
Okay, I'm not aware of that.
Something like that this year only they started. The description matches.
Okay, I was not aware of that. But there's a similar course in IIT Delhi, which is called ECM, which is Engineering and Computational Mechanics. I think there's a lot of similarity, but also a lot of dissimilarity also with that course. And I think that ECM course has been running very well, especially in terms of placements. That's what I have heard, because these are things we were taking feedback when we were starting this program. Because we can't run a program without keeping in mind the future prospects of the students. I think the IIT Delhi, the first batch of graduation was last year or the year prior to that. So this year, either it's their third batch is graduating or second batch is graduating. I'm a bit unsure about that. I don't think so.
Is there any increase in seats this year? Last year they were very few,
40.
total capacity, and last year was it lesser?
No, it was 40. So any other questions? Yeah.
In this new CEM course, there will be a special focus on computational aspects of this, say CFD or element analysis.
That comes slightly later. For example, in the first semester, right? We have a program. We have a course on which is basically Introduction to Programming and Lab. We assume that from class 2 you are coming with zero knowledge. So it's like Introduction to Programming, and there's a lab associated with it. In the third semester, I think these guys will be doing. I will be teaching that course. We have a course called Numerical Methods and Lab. So that's basically essentially a computational maths course. So we will be teaching how to write from error analysis to how to solve simultaneous couple linear equations, do nonlinear algebraic equations, solution of differential equations, solution of ordinary differential equations, PD, partial differential equations. So this will be the Fourier transforms, other transforms. So this would be the numerical methods course, which you do in the third semester. In the fourth semester, we have a course on data science and fundamentals of data science. Okay, so by that time, see, all this has to go hand in hand with maths courses, because computations and maths you have to be very strong. So we have purposely kept that course in the data science course in the fourth semester, because the students will be doing the linear algebra maths course also in that semester. Okay, so the linear algebra is the foundation for data science. Okay, then in the fifth semester is where you have the finite elements and CFD. So usually finite elements and CFD are courses that are part of the curriculum for only master's students, master's program, number one. And number two, it's rarely that the students will be proficient in both FEM or CFD. Usually FEM proficiency is for students who work on solid mechanics, focus on solid mechanics, and CFD is focused on where students focus on fluid mechanics. Here, our students will be doing both. Okay, and you can do FEM and CFD only if you have good knowledge about solid mechanics and fluid mechanics. So by that time, in the fifth semester, you would have done two courses on solid strength of materials and solid mechanics, and also fluid mechanics and advanced fluid mechanics. You would have done by that time those courses. Okay, and we also have in the fifth semester digital twins. So which is again, you have to combine at the end of this semester, at the end of semester 5, you can actually create a digital, we expect that we will be able to create a digital twin. So you would be integrating, doing finite elements, CFD, everything combined together, you will be able to do that.
I wanted to ask, these are very similar courses to what a mechanical engineer might encounter. So how would a CEM engineer approach these?
Yeah, if you look into the mechanical engineering curriculum, actually this was a shock to me. But when I was in one of my electives courses, about 40-50 mechanical engineering students signed up. It was a higher level elective course, and I did not know. I gave they were all third year students. I think 7th semester, 5th semester, 6th semester students. I gave my usual term projects and all, and they were all very computational. And then I got to know that they don't even go through any computational course in their entire curriculum. Like, I mean, apart from the basic programming course, they don't have a numerical methods course. The finite element and CFD, they can only take it as an elective, okay, which comes only at the end of the at 7th semester onwards. Okay, so here we are, and it's unlikely that you would be doing both. So here you are becoming proficient in both these things. And nowadays you can't. There are so many things. If, for example, if you want to analyze that morphing wings, where the structure shape is changing as it moves, you have to integrate FEM and CFD. You can't do only FEM or only CFD. It has to be integrated. And while you can use softwares to do it, if you don't understand, it's like garbage in, garbage out. Okay, you have to know the physics associated with it. Okay. Yes, it is. You please go to our department website, apm.iitm.ac.in. There's a tab New Programs. In that, under New Programs, you will see this both these UG programs, IBME and CEM, and their semester-wise we have given the entire course. Okay, the core curriculum and as well as the electives, those are all given. We have listed, another thing is we have listed under electives, we have so far listed only our department course, but when we define our electives, we are not restricting our students from taking courses from only the department. Okay, they can take courses across the institute, whether they will be professional elective or unallotted elective, that will be a discussion between the student and their faculty advisor. So you can actually tailor your program very well. Yeah.
What are the targeted industries you are looking at for placements or something?
See, I mean, core mechanical sciences industries, we had talked to GE, those motor companies. Then we had talked to Honeywell. We had talked to I forget. I mean, we did do a lot of survey. So many. I think there were. We didn't find a Siemens. We didn't find any problem in terms of companies. I just can't remember the names right now, but there was no issue with that. In fact, industry was, many industries said, I am ready to recruit at least 4 people today if you give me as graduates.
And for higher studies or PhD, what are the areas they can?
Actually, that's a very, I would say this program is perfectly geared for higher studies in the sense that you are really being trained in very cutting edge areas and with a skill set that encompasses multiple disciplines. So abroad would not be any problem at all. In India, if you want to do higher studies, you have to write GATE. So GATE is a problem because there are no CEM paper. So what we have been working on this. We have already started in GATE one paper on this related to this. So this will be available from 2027. So this GATE paper will be basically, we already have an XE paper. That is, in XE paper there are multiple papers of which maths and I think one other paper is compulsory. The other, you have to take one more. So one paper related to this will be coming from next semester, next year, 2027. And this is being done in coordination with IIT Madras. IIT Madras has taken the lead, and we had reached out to IIT Delhi. We have IISc also, the new program. They have also participating in it, as well as I think this ECM is also there in 4 other NITs. Okay, so there is enough already mass available to have a separate paper for this. So it should not be a problem. Abroad should not be a problem at all. Okay, we have many of our MS and PhD students are there. We have been running successfully this MS program and PhD program. Our MS students and routinely get placed in very top places for PhD, if you are talking about. Okay. That GATE paper was an issue that we had been working on. We were aware of that. We had been working on it, and we have already started that. So we are expecting it to be available from 2027. Any other questions? So this is actually the other question that was that in IIT Madras we have this option of upgrading to dual degree. So traditional departments have that option of upgrading if you are doing mechanical engineering, for example, or electrical engineering. At the end of semester 5, if your CGPA is above 8, and if you desire, you can upgrade to dual degree program. Now you can do it in multiple ways. You can upgrade to dual degree in, say, mechanical or electrical or whatever is your core discipline, or we have now 15 IEEE programs, interdisciplinary dual degree programs, which you can upgrade to. Now, from our department, we didn't have a BTech program, but we had been running 3 or 4 IEEE programs. I myself coordinate one IEEE program on complex systems and dynamics. And then we have the computational engineering is also another IEEE program that we run as a department. So that computational engineering was already there. Okay. So then we have also IEEE on, I think, energy systems. And one more IEEE, biomedical engineering. So as a department, we are running 4 IEEE programs. So students from our department of these programs, if they want to upgrade, they can anyway upgrade not only to these 4, they can upgrade to any of the available 15 IEEE programs. Okay, so it's not a problem at all.
So for EE also they can go?
They can go. No, EE they cannot go because EE is a code. They can go to non-core students can upgrade to IEEE programs. Yeah.
Is there any restrictions or number of students who can go for a particular?
Yes. There are restrictions. Unfortunately, like the number of seats in CEM, there are restrictions everywhere. So we have a finite number of seats, and yeah. So we have IEEE on, I think data science is the most sought after IEEE program. We have 75 seats there. We have robotics, I think, the rest of all the IEEE programs have 30 seats. Robotics, computational engineering, complex systems. In the order of preference, usually these are the most sought after: the data science, robotics, computational engineering, complex systems and dynamics. These are the most sought after. We have also IEEE programs on cyber physical systems. We have on quantum computing. We have several other 15 in total. 15 now we have another one on electric vehicles. So we have a lot of these options available. I think this is one of the key issues of IIT Madras, which is not available in other institutes. This flexibility.
Selection is on CGPA?
CGPA. And attendance criteria. So if there are people who are having the same CGPA, then attendance comes into the picture.
We will have to start the session at BTech at 4.
Sure.
If you can exhaust all your questions in the next 2 minutes, that will be really helpful. So join us at
Yes, I think they are exhausted.
Can you thank the professor? Thanks.
Yes. Thank you and welcome to IIT Madras. And wherever you go, whether you're in IIT Madras or in wherever, I'm sure all of you will do very well. And I wish all of you the very best in your career. You're just starting. All the best to you. Thank you. Only one video was not there working. This video was not working.
Mr. Kama said he'll come at 4. So I'm going around.
Okay. This is now what session is this?
We had a placement session, and then 5 o'clock was Professor Kama's session.
Okay.
But his office said he can only come at 4.
Okay. So what is it I want to attend?
Kama's speech.
Yeah.
He will mention patronage, he will mention naval architecture,
Yeah.
he will mention
You
operations.
mentioned naval architecture having Rolls Royce.
Yeah, and yesterday he looked at Ravinder sir and said, he only has a bunny room. Then some people ask questions, he answers in his way.
See, this is, first of all, this vertical branch is, I came to know only after talking to people. I don't know. I mean, this is, they will be doing 3 basic electrical engineering, signals and systems, digital signal processing as core courses. And one elective that I am suggesting all of them to do is that digital systems, where you learn about embedding circuits and all that stuff. Again, this will be offered from our department because it's a core course for our IIT students. But at this point, the students are doing the same courses as any other electrical engineering students would do. So they are not missing out in any core thing. After that, if they want to take electives, then they should be able to, they are primed to take that any other elective.
We have not yet started our things, but it all depends on basically the placement.
இல்லை சாரிப்பா அதான் எட்டி பார்த்தா வந்தேன்